quite understand that it's a different window. Give me just a sec. There we go. Let me share this up. So let me get the video back up so you can see my pretty face, maybe, or not. Anyway, so typically when I start designing, can everybody see the diagrams? Everybody's cool? Well, it looks like that's coming from my feed anyway. It's good. So typically when I start designing any system, I start with boxes and arrows. So, it's really about just, figuring out what the pieces are and figuring out the relationships between them. So figuring out the level of detail you need to diagram out. I mean, if you're doing a back of the napkin and you're just working through, whiteboard, I use Tinderbox when I'm whiteboarding by myself. Great application, Tinderbox, really weird and old school hypertexty, but check it out. But I usually start in Tinderbox and I start putting boxes there and figuring out what's what. The problem is like as the size of the system grows, the diagram inevitably goes out of date. So what I wanted to do with Tansley was kind of the age-old UML dream, which is generate working code from the diagram. And I did some initial kind of prototyping actually using Tinderbox because it has an export functionality. But ultimately, it didn't really kind of produce quite the user experience I was looking for. I should also actually pause for a minute because I'm not sure how familiar everyone's with. So the tool I've been working with a lot is called Terraform. It's infrastructure as code. So conceptually, the thing about infrastructure as code is basically that you describe, like you declare, it's a declarative syntax. You describe your infrastructure, like the infrastructure that you want the system to produce. And then the software, in this case, Terraform, figures out the right dependencies, the order, everything it needs to do to create those resources for you in the cloud. There are other methodologies for it. CloudFormation is one of the key ones for AWS. The problem is that writing that much JSON is kind of shitty. And it doesn't actually support all of the features of or all the AWS services because they're constantly coming out with new stuff. So typically Terraform actually has a faster implementation because it's open source and somebody who needs that service just goes and writes the code to get it done. One of the alternatives to that is Pulumi, which is I'm seeing kind of gain a lot of extra weight. The problem so Terraform works, but it's incredibly verbose. It's very difficult to figure out how to structure things optimally, and you're gonna do a lot of copy paste for something that has modules. And like it has a modular system, but like it's not very composable at the end of the day. Pulumi is written in like your preferred language of choice. The problem I have with it is being a Lisp guy is that it's not very declarative, and it tends to encourage people to do things like side effecty things like loops and whatnot. So given my priors, like I come from the Clojure community, we believe in immutable data structures. We want to keep side effects to the edges and under tight control. We believe in coding with data, and the data structures matter, and then also us being Lisp hackers in general, code is data. I feel so with infrastructure as code, we have all these different tools, but ultimately, like it's really about manipulating data. Initially the data about how you want the system configured, and then later, mapping that onto how, like what the actual state of the system is. There's been a lot of work in this area. I know HashiCorp, who is the company that makes Terraform, is having their conference this week, so I'll be curious to see what they announce. But this is a hard problem. And to some extent, the level of generality that we get with Terraform makes it a harder problem because there's no clear place to start. You've got to have very strong opinions about how to structure your system in a way that's going to also be sustainable and manageable going forward. And considering most of us are all coming off of not having any configuration or specification around this. I mean, okay, like I was a long-term Chef user. I was a long-term Puppet user before this. Obviously Docker, is a key technology. but there's nothing to pull it all together. And so really what I wanted to do when I started designing Tansley was like, let's get this all into a blueprint. Let's get this into a map. And again, I mean, I'm going to show you the wireframes because the rendering engine isn't really up to snuff. But I really wanted to get something where you could get into the system and look around in a way that currently you can't do. Now, the other cool thing about like data-oriented development around this, so biggest, I think basically coming from Common Lisp, when I was using Terraform, I felt like the biggest problem we had in terms of drawing out our code and creating like reusable components was we actually really needed a macro system. And I've seen a bunch of people make attempts with just using, you know, various templating engines like ERB and like some of the other ones from different languages to try and create essentially macros on this language. And I think this may be one of the biggest drawbacks to Terraform in general is I think HashiCorp made the wrong call in trying to create a new language. Like I can guarantee it, like it was totally a language nerd sitting there going, oh man, yeah, we're gonna build all this stuff. And then like, you know, getting into production and going, oh shit, we've got to create even more stuff. And I mean, version 2 is way better, and I've actually read the developer's blog, and it's not a bad language exactly, but it was clearly created with from a top-down perspective as opposed to coming from an experiential idea of like how to do this stuff. So what kind of started me on the path to developing Tansley is that with Lisp we have so many more tools for composing data, and you know the concept of read time versus compile time versus run time, having those kind of separations is exactly this problem. It's like, because like runtime at this point is like applying the recipe. So if we could find ways to create like more abstract data structures around this. That said, you know, as I said, I'm concerned about like Pulumi and people getting a little too procedural. But in the Clojure world, because we're so data oriented and so functionally oriented, it's less of a risk to introduce the full power of the language into the mix. So, you know, I should take a step back for a second since I don't have the demo to show you right now. Tansley, the idea is Tansley is it's a CAD application. It's AutoCAD for cloud infrastructure. So, which AutoCAD also being a fantastic Lisp supporting environment. And anybody who hasn't played with Auto Lisp, it's kind of neat. It's old-fashioned Lisp, but interesting. So the idea is that basically that I started from a concept that I wanted to be able to use Clojure data structures to output to Terraform JSON. For the first version of Terraform, that wasn't really possible because they had different parsers. So the JSON output or performance it didn't map one-to-one to the HCL. HCL is the language Terraform uses. Version 2, they're now one-to-one. So we kind of lost that ability. But the problem I ran into very quickly is that like expressing variables and things, like a friend of mine, Tiago, did a version of this back for the first HTL1, and he had to use macros to do things like variables and string interpolation and things. He was essentially replicating features of HCL in the thing, and I didn't really want to go that direction. So I started out by like designing the data structures that I was looking to create. So let me get out of full screen mode so that this thing actually works. There we go. Let's try that. So I was looking to kind of create just raw Clojure data structures of some sort. I'm not entirely happy with the syntax yet, but there was figuring out an effective way to differentiate between blocks versus like individual variables. But I really wanted to basically have something super clean that reflected the structured code, almost maps very cleanly to JSON. But then we immediately run into the next interesting problem, which is like, okay, how do we do variables? How do we do string interpolation without actually re-implementing HCL in Lisp? And the solution that came on is like, let's take it up a notch. Let's get rid of the variables and things, and let's kind of, well, I mean, ultimately going back to the boxes and arrows, you know, let's work at that level. Switching screens is going to be fun here. Maybe I'll just try my entire screen for a second so I can switch back and forth. All right. So the boxes and arrows are actually the thing that we want to model, and that variables aren't really variables, they're links between the various boxes. And this basically helped me kind of think through a tool that I had played with a lot, but hadn't really gotten to use a whole lot professionally, called Quartz Composer. And if anyone's used it before, seen it, I know Facebook was using it for a while to prototype mobile applications. And Quartz Composer, which maybe I can pull up a screenshot of it. It's no longer included in Xcode like it used to be. But it's basically built around the idea of like audio patch cables. So the idea is that you create a patch, and this is decent enough. Let's zoom in a little bit. The idea is you create an audio patch. It has inputs on one side, outputs on the other, and then you literally drag and wire these things together. Now, what's beautiful about this concept is that you can look into a system and have a really good overview of what relates to what, where things are in the system. So using that kind of basic concept with Tansley, I basically built a data model that would model this, where it's like you have nodes, which are basically the individual patches, the individual resources in Terraform terms, and then we have links between those nodes. So in some ways, it actually is a simpler version than the way they went about building it in HCL. Because I don't need to do, I don't do string interpolation as some kind of weird syntax. Instead, I put a string interpolation function between the two things that need to talk about it. So started out modeling it this way in the database. What's cool about it is that once you start thinking about your Terraform and your resources in this way, adding a visual representation is, and I realize it's kind of hilarious that, because I don't have an example right now because of the renderer, but and we can go into why that, like what, blind alley I steered myself into on that. And I think we've all been there, but is that, it immediately lends itself to a visual representation. So even if we're, working in code, working in Clojure data structures, with all the beautiful full power of Clojure, composability and all those things, and we still actually have this visual representation that doesn't require, well, so like the interpolation syntax, right, for Terraform looks something like this, right? And we're doing like variable foo or whatever. So getting rid of all of that and making the links between the resources more explicit actually makes the system easier to understand. Now,
so I have a question.
Yeah.
So it's I understand what you're saying about moving things into you're basically translating into a graph.
Yeah.
Right?
Because there's already a graph.
Yeah, but it's probably not syntactically that, or at least conceived of that way in Terraform, right? That's what you.
No, actually, it is.
Okay.
Oh no. So all right. A little bit more on kind of the internals of Terraform. Terraform basically has a schema for all the different resources and different providers.
Mm-hmm.
Unfortunately, that's all expressed as static Go data structures,
Mm-hmm.
Which I'm going to probably have to hack a library together to get a good export. Although there's one for IntelliJ that the guy uses for the IntelliJ plugin to export all that to JSON. But no, so Terraform basically, it does its first pass, and it basically organizes the entire, all your code into a dependency graph. And then it figures out what order it needs to apply those changes to get your current state to your desired state. So by its nature, it's already graph oriented. All I want to do is pull that up to the developer level so you can actually see that. The other, the other half of that approach, or like what I'm attempting to do there, is also get into, to support a graph-like data structure, you need a database that can, do that. So obviously, I'm a big Datalog fan,
Mm-hmm.
but I very much wanted, one of the things that's like a big for me, and actually, you've seen Tinderbox show up on my screen a little bit here. One thing that's very important to me though is supporting local only work. So like the data exists on your device first, so you can work offline. I actually just came off of working out of rural Tennessee where the internet's not so good. So being able to have stuff that's local is very valuable, but also having access to your data in a format that's usable. So Tinderbox uses XML. I'm using Eden, which is essentially the Clojure version of all of that. The advantage of having that is that means that even if it provides additional security that if you put all the effort and energy into using an app, you still can get your data back out, even if that app goes away. So, it's sort of a data security perspective on it. But yeah, no, so Terraform's already got the graph baked in. What I want to do is make the graph explicit. And one of the ways I've done that is, at least in the prototype I'm working on right now, I'm not using Datalog, I'm actually using a great in-memory database called Datascript. And Datascript gives you a full Datalog engine. You can query everything against that. You can define the relationships in the schema. It's a little looser than Datomic, and it doesn't provide like the history component as much. But the experience we're working with has been fantastic, to the point where like I don't even want to like. It'll be my default for it. Like there's no reason for me to stick to atoms anymore for the most part, unless it's something super simple. And it's very performant. Like I've actually been kind of stress testing it a little bit in the browser. I mean, sure, it'll use memory, but it'll use less memory than my like crappy array implementation. So at the end of the day, what's cool about that though, and I hadn't even thought about this when I originally started the product, was that, all right, so I regularly build systems from scratch, but 99% of everybody else is going to be coming into existing systems, having no clue what's what's where. Or you're coming in and you're coming in a system and you're trying to figure out like certain issues, like maybe even trying to get cost data or whatever. But the ability to query using a proper language like Datalog to query your infrastructure and say like, okay, well, how much are we spending on this, or how many resources like this do we have, or what's connected to what, is incredibly useful, and it's way better than going through the source code. Because again, the source code, like, yeah, okay, I can load all that into my head, but it might take me like a few days. Whereas if I can poke and prod at the thing as well as looking at it in map form, that's fantastic. And what gets even more interesting is when you couple that with the server side, and we're persisting this back to an actual Datomic instance, you can now query how your infrastructure is changing over time, which anybody who's had to walk into a legacy system will know that that's an incredibly valuable ability to do it. And
absolutely.
And one of the things that I really want to do is Tansley, my initial goal was, let me just get, I actually used my static site module, which you can find on my GitHub, for what I use for create my website, like an S3 bucket, a CloudFront distribution, SSL, just a few things, right? My goal is basically to get to a point where I can build that and get it outputting to Tansley and be even. But when we start getting into some of the more complex, things, there's so much we can do here. I mean, the biggest problem you run into with Terraform is chicken and egg. Mm-hmm. So I need my remote state. I need all the infrastructure to store my state remotely so I can collaborate with my team, right? Mm-hmm. But then at the same time, you've got to also create that through Terraform. So you end up with all these kind of bootstrap phases. And I know one of the other big tools that's a wrapper around Terraform is called TerraGrunt. And they actually have some magic around handling that for you offline. But what if we had the equivalent of Photoshop layers? You do a layer of this, and it's going to do this thing, and it's going to do this. There's so much more we can do around this from a visual standpoint. We'll make it way more intelligible than just simply the code. And then add on the ability to query against that. And then eventually layer on the ability to actually store the state or represent the state in the application. And we can now start writing, we're not just writing code that compose data structures to generate resources. We can now write code that's going to be actively managing the infrastructure, like agents that are oh, hey, there's this thing. Or, you introduce compliance. There's so much we can do when we can kind of pull the process apart a little more. And I think it's probably why no one's kind of done that much work in this area, I think, is that, Go's a statically typed language. And I get around in Go, it's useful. I actually don't have any problem. I actually learned it reading the Terraform source code, ironically. It fixes some of the dumb things about C, including actually switch fall through handling, which I literally laughed when I saw that. Anybody's done C, anyway, it fixed all the annoying things about KML. But at the end of the day, like I think that static mentality is also permeates kind of the overall architectural approach. Now, some things should be static. I mean, I love declarative. You don't have to test it because it's just going to work. I mean, if you test the underlying code applying it, then you're good. And one of the risks I think that people run, and we're seeing this a lot within the Terraform community, where people are trying to do these complex looping constructs, and they're trying to overly dry up their configuration code to make it really reusable. They introduce a position where now they have to test the Terraform code, which kind of completely defeats the purpose. Whereas if we could actually pull out all the things that generate the code, test those, and then we don't know the code's just going to work, it makes it much easier to reason about the whole system. So it's not, it's a, okay, sorry, I hit a blank where I was going with that one. But at the end of the day, like what I'm trying to do is make a lot of these things more explicit. Let's get harder into the declarative. Let's get easier, but then still have the tools to create bigger systems. So and bigger systems across the team and that are intelligible to the team. Now, one thing I will point out that's been interesting is, I'm obviously working from the REPL-driven development, the usual. That actually hasn't been that useful when I've been with my experiments around actually creating Terraform. It's been useful, obviously, in creating the application itself. But because of what we're talking about is so static, you don't need the interactive development as much as I thought I was. Like, I thought that would be a really cool feature, and it's neat. You can do cool things with it, but it's not that useful, especially when you start thinking about collaboration or how we do it. Other big things that I'm kind of looking into is obviously change control, not just from the Datamic standpoint, but knowing who changed what and when in a useful way. I mean, I think we've all used Google Docs and done some of these other interactive systems, and there's a reason we keep falling back to Git. Git's not fantastic an experience point, but it works really well because you can have a very clear responsibility of who did what when, and you can have a chance to be like, okay, I'm saving off a cut now. Either way, I think ultimately we're all going to have to deal with this stuff down the road, or some of us already are doing it. The systems we're building are getting bigger and more complex. We need more visibility into how this stuff actually works, even if you're just a developer and you don't necessarily understand what this particular service does or whatever. If you're deploying into a particularly as I've been doing a lot of serverless, if you're doing a lot of serverless stuff, you still need to know how that thing impacts with the larger system. And right now, it's really difficult for a developer who's focused heads down and actually doing implementation, like functional development or whatever else. It's hard for them to get their head out of that and then go okay, this is why I did this is why I did this. Even a simple visual representation that also matches the state of the system, I think will be an enormous enhancement for everybody. And I'll be shocked, honestly, if I don't see at least somebody else attempting to build this kind of thing. But it's obvious, but at the same time, it's not something that people would attempt, because I mean, the kind of people that are usually working in infrastructure, we're super code based. We're in the code base all the time. It's in our head. We got the map in our head. But finding ways to basically make the system more intelligible to everyone, more maintainable, and more shareable, I think is going to be the order of the day going forward. And I don't think Palumi's method of, okay, you get to use your language you're used to and you just modularize. I think that's actually going to make things more opaque and less transparent. So I think a lot of the philosophies of Lisp and of Clojure are kind of a way forward for, I believe that even just for regular code. I think it's doubly so for infrastructure code. The more we can be declarative, the more that we don't have to worry about the logic of the system, and we can just specify what we want and let the system do the right thing, is absolutely correct. It's what drew me to infrastructure as code in the first place. I'm kind of down to the end of my notes on what I was going to talk about. Oh, actually, before, real quick, let me kind of give you a quick wireframe look of what I've been working on. Let's do that. And so I've been sketching an omnigraphal for a bit, but conceptually, can everybody see? Yeah, we're good. All right. But conceptually, again, it's just like Quartz Composer. The idea is you've got a hierarchical thing here for all the inputs and then all the outputs. Now, there's some very interesting engineering issues around making things not get too messy. But one of the philosophies that I also have around a lot of this is that we want users to be able to drag things into the arrangement that they want, so that they can basically use their spatial memory to remember where stuff is. It's obviously into just being a gigantic graph and flow. This is a super simple example for just creating a S3 KMS key. There's some experimentation. I actually haven't implemented the functions yet and the data structures. But what I'm thinking is we could end up with a way more complex computing model than what HCL supports, while still being visually a lot simpler.
Wait, what's HDL?
HDL is the configuration. It's HashiCorp configuration language.
Okay.
It's the language that they use across all of their various products. So they use it for Vault, or what I'm sure Vault for Sentinel and some of their other products as well. It's a vaguely let me see if I can find a good example here. It's a vaguely Algol style language. It works, but it's super repetitive, so it looks kind of like this. But it also, the new HCL2 also is like isomorphic with JSON. So you can write it in JSON or you can write it like this. I usually stick to this format because IntelliJ does autocomplete really well. But yeah, no, so that's pretty much, mute that, there we go. That's pretty much all I've got. Would love to have a chat with people about their experiences with either Terraform or thoughts, questions.
Well, I have another question. Actually, I wanted to if you can show us how when you represent a graph, how do you represent the links?
Sure.
Between the components.
Sure. So I'm getting a lot out of Datalog there. Let me share my screen again really quick. So I don't know how many people are familiar with Datalog or Datomic. I highly recommend check it out. It's a really interesting piece of technology, and they don't really do. So it's coming from SQL. It's a different way of thinking about it. It's based off of Prolog, which I guess folks would typically be a little bit more familiar with. So the general way is that basically all I'm using is DataScript to define a certain schema. Now with DataScript, unlike so in Datomic, you would define the schema in detail. So every single value or field or whatever is going to be in there. And the system is not explicitly row-based or anything. It stores a datom, so a fact. It's a fact-based database. So you have this concept of called entities. So when you issue a transaction, you can basically define a set of different facts that are all talking about the same entity. So in this case, I'm basically defining, all right, an event stream. I'm defining all the links for a particular canvas. A canvas would be just sort of like your base layer. And then a node would be kind of the same thing where I have inputs and outputs. And then we have a link, and a link is just from one output to another input. And we're defining these as type ref. DataScript, you only have to define refs because otherwise it just does the right thing and stores them by value. Datomic's a little bit different. And then we kind of get deeper into the different schema. But because when you're querying it, it ends up looking like something like this. You end up with this seemingly relational query where we're finding something, we define a where condition. In this case, I'm looking for every event stream, and then you just define the relationship. So if I cared about this output, I would declare it. But in this case, I only care about something that is on the receiving end of it. And as a result, it makes it really easy to do graph queries without some of the more explicit approaches with like Neo4j or whatever else. It's not explicitly a graph database, but because of the way it's designed, it's you kind of get the graph piece of it for free.
Mm-hmm. That's cool looking. I like the idea of you know, especially the idea of using Datalog for querying. I think, or using Prolog for infrastructure querying. I think that's.
I think that's.
Especially if you can even add like you know, like live states. Like, okay, here's this component. It's currently live, or show me all these components. Show me their status and things like that. There's definitely a lot of potential for that.
Yeah, I think it's going to be incredibly powerful, and then that's kind of where the interactive development comes in to start being like way more interesting to me, because you know, as I said, I've done some experimenting myself, which is like, okay, if I were using this for real, like what would, and I'm, you know, because I've obviously got the database schema working, I've got, you know, the data export working, and I started to kind of code with it, and it's like, okay, do I really prefer writing Lisp data structures for this over just doing Terraform? And with the lack of IDE support, no, I don't. It's actually a pain in the ass. However, I think where things are going to be really interesting is where you can just go in and run arbitrary queries on the state of your infrastructure interactively and dig into particular problems. Like if you're debugging a particular issue, or there's some component that's failed, or there's even environmental drift, being able to also go back and interrogate like whose change last like impacted that, and like what was going on, and get the history of it. Starts to get really interesting. So like, you know, the base version of it looks like the wireframe I'm building, and that's useful by itself because, hey, I'm already drawing the diagrams as I go anyway, so no reason not to make that the editing experience. But when we start overlaying this additional data, we get these layers. We're even also again having the computer help provide feedback on the system. So again, if you want to implement certain kinds of policies, or, you know, like instead of having just Terraform's module system, which is super bare bones, what if your company has a function you can call that creates a certain kind of infrastructure that's already compliant with everything else? It just gives a lot of flexibility, and in some ways sucks a lot of the complexity out of Terraform. Like if I can get this thing built like, you know, fast enough, I feel like I could actually almost make a case to HashiCorp that, hey guys, you don't need to invest so much time in your configuration language. We could pull all these features out if we just tackle them a little bit differently. Mm-hmm. But you know, obviously that's the dream. You know, and actually to go into like why I don't have a demo today, like I made a gamble. I kind of, you know, had two choices on the rendering environment. So I got all the data stuff working and feeling good, and that's maybe useful, but not quite where I want to be. And started doing the rendering, and I kind of went down an SVG rabbit hole. And the biggest problem I was running into is I was using event listeners, which is kind of solved from the schema a little bit. And every element gets its own event listener or whatever. But the system I was using to render out the SVG would reuse HTML elements, and so figuring out, and didn't provide a good way to like know when that was going to happen. So there was no way to remap event listeners. So I'd get a node that thinks it's node 42, and it becomes like node 43, but it's got the node 42 event listeners on it. So that combined with some just general performance issue about like once the graph gets to a certain size, gets a little messy. So I may very well have to just bite the bullet and write my own 2D rendering engine. I was just really trying hard not to do that. But
what about using something like D3?
It wouldn't scale up for this. Well, some of that's architectural. Like I'm very much going with a reactive design. Coming out of React in years like of that, it works really, really well. Mm-hmm. And actually the event model that I have, I think I'm very happy with. It's just everything has event streams. There's a multi-method that processes them, and the data, you know, everything happens in a very nice way. The real issue is like what I'm really looking at right now is probably switching to Canvas, and it'll take a little bit more infrastructure to like kind of actually render, but you know, it's still boxes and arrows at the end of the day. So I just got to dig into that. I was just trying really hard. I mean, actually, long term, that's probably even a better bet because you get the GL benefits. But you know, I was trying to get away with just using SVG and JavaScript's existing like event listener model, and I'm not sure that's going to actually. It's not looking like it's going to scale up the way I need it to. I'm doing my best to avoid writing any native code or dropping all the way. Like, I guess originally I was considering just running this on Java instead of Clojure script, on a JVM and just going full OpenGL. And I guess that's still an option. But it means like my code size is going to balloon massively, which is unfortunate. So like, I got a nice trim schema, but the problem with UI code is that's always like the biggest piece of the project. And the gamble I made on saving some time just didn't work out. That's how it goes sometimes.
Well, I had to say, personally, I kind of like, I always like the text-oriented view more important than the graph-oriented view, especially if you can manipulate it. And I really like the idea of like using a database to query these, query, like this is really a giant data structure of your infrastructure.
Yeah. Right,
that gets written into code, and to be able to query it to understand how things are, or even better, maybe even create constraints. Especially if you use something like Datalog or a Prolog, where you can create constraints.
Yeah.
And then, when you do something, it'll tell you, you're violating this constraint. That would be a very interesting.
Also, I'm not sure.
I don't think anyone's ever done this before. Actually,
like if you guys are familiar with Clojure Spec, which is still very much a work in progress. But it's a way of expressing constraints for like, functions, variables, or like describing how your system works. And it's sort of like kind of gets you what we used to use TDD for at the end of the day. But the great thing is you can basically put it into your system and only execute it at a certain time. And then the way the specs work too is it can even tell you what valid inputs are. So you can actually do generative test design. And the way I really kind of see that growing for this kind of thing is doing the same thing for infrastructure, is developing infrastructure specs that are testable, and to the point where we might even be able to use the spec to generate the infrastructure code in the first place. Really cool.
Yeah.
And I think this is definitely the way of the future. I guess I've been working hard properly on this since June. But at the end of the day, it's I keep saying that today for some reason. I guess because we're at the end of the day. I'm actually not used to being in my apartment at night. I'm used to like being out. So, but still getting used to New York under COVID. But yeah, no, I think there's a lot of potential here. And like even if for whatever reason I can't get the front end portion of the application working to my satisfaction, while I still think the visual component is massively valuable. There's no reason why pieces of this can't be shaved off and released independently. Like I could probably put out an individual library just handling the schema and that portion. The only catch there is that I'd probably need to spend a lot of time doing proper import with HCL, which I'd really rather not write an HCL parser. Like that's just not, they're having enough bugs themselves. So if I could find a way to like avoid that, because otherwise nobody could use the library unless they could import their existing infrastructure. Now, granted, I still have the same problem, and eventually I'm probably going to have to bite the bullet and do it. I'm just not in the mood to do that much Go right now.
Yeah. Well, I think especially export is probably the main thing to start with.
Well, export's working. It's trivial to translate one Clojure data structure to JSON.
Yeah.
I'm actually using the Eden library, the Transit JSON library, because it has much faster output, like rendering output. But also I have an Eden output as well. There's a lot of that was the trivial part. Of course, it's the first thing I built. The hard part is actually getting the UI right, and I had to get something. And then to be fair, like this past month and a half was not a waste on the renderer. I got it far enough along in different ways that I was able to test out some UI concepts that I couldn't do on paper and kind of get a feel for what it's looking like. But you've got to be able to just be comfortable throwing stuff away when it's not working. And I mean, certainly this talk felt like a deadline for me. And once I realized no, you're not going to make it, dude. It's not going to happen. That kind of helped me a lot, being like, all right, fine, fuck it. We're going to toss it. Like, let's just stone it. So hopefully that's not too disappointing for everybody who's like sticking around on this. But I will get there eventually, just because I don't like to lose. The overall concept feels very interesting to me. And even if the whole app doesn't necessarily work out, I guarantee the querying piece of that will be valuable going forward for people. And ultimately, if I don't get the app to where I want it or other things come up, I'll try and package that piece up in a way that's valuable and release it. It's, you know, open source lib or whatever. Because again, I think that there is something worth discussing about that. All right, so I've been talking for a long time, y'all. Questions, concerns? Do you like my hat?
So I had a comment about the whole like graphical versus textual thing that Arthur was saying. So his view is that obviously the seeing it as text is pretty helpful, but when it comes to a graph, right? When it comes to a graph with like many edges and many nodes,
Yeah,
there is no good textual representation for it. You need the graphical representation to really see the shape of it.
Yeah.
So, you know, the textual representation is good for being able to modify, manipulate, sometimes to be able to analyze it. But sometimes you need that graphical representation so you can actually see what's happening in your system, right? You can actually see you can see the network as a network, as opposed to a network as a series of nodes, and then the connections are kind of buried in that list of nodes.
yeah.
You instead see the connections as first-class objects.
Well, and then also the ability to like overlay additional data on that, like on that representation. Again, like we're all way more visual than we pretend to be. I mean, hey, we're all in our heads. We do a lot of abstract work in this industry, but there's a reason we still get around a whiteboard every day, you know, and you know, having that visual memory and having that understanding of the system, even if it wasn't directly useful, it gives you it stores your brain in a different way than like, all right,
Yeah,
having to load this entire thing into my brain at the beginning of the day. So that's been kind of my instinct, you know, from the beginning. That's why I'm really, to me, the visual part is absolutely critical, despite all the cool query capabilities and all of that. And then on top of that, to have a shared vision. I mean, obviously remote work. All right, I've been running remote teams for years, most of my career actually. Now that remote's even more important, where we can't get around the whiteboard, having that shared understanding of the system, like I think it's going to be absolutely critical going forward.
yeah, absolutely.
Well, the question that raises for me, though, is for a large graph, there's usually no clear 2D graphical representation.
Yeah. Well, so exactly. Well, I mean, you even see that with like my wireframes is that it gets messy. Like the concept of auto layout is kind of out. I mean, it's not out. It's hard. I was talking to a company a couple of weeks ago, and they're doing business process design, but they go from natural language to a diagram. And so we were riffing a little bit on the auto layout issue. I think that like auto layout, yeah, is great. It's nice to have. It would not be the first thing I would be tackling. Mostly because I do think, you know, and I use the app Tinderbox and I do mapping. I think it is important for people to actually physically move boxes around on the screen and know where things are, because they can cluster them. It's part of the interactive and like memory process, right? The other side of that is that these systems get real big, or can, right? Excuse me, can get really big, but at which point there's probably no sane graph that actually like is going to be entirely visually intelligible. But I think that could actually be a massive advantage over our current approach where we just shove all the code in a file. Because once you start, things get so visually noisy that you just can't keep up with it. Maybe that's an indication that you need to modularize a little bit. You need to make some adjustments to the layout so that it actually makes more sense. So I feel like the visual component of it can actually steer towards better design versus like, okay, I have 15 files in a module and that's what we're, we'll just add another file to the mix. You know, by making it more visual, forcing people to think through how they're designing their system a bit, because maybe when you see visual complexity, you're like, okay, that's visual complexity. Maybe I need to actually simplify something here. Like that making me feel a little uncomfortable.
Yeah, I think there's that, and maybe you can use, like you were saying, overlaying additional information, like maybe the number of network connections that are happening between the two, like, or the amount of bandwidth that's consumed between two particular nodes in the graph, you know, whatever else, right? Whatever you want to look at.
Well, we're going to go back to like the layers idea too. Is like, what if I just want to see these kind of resources or these things that fit it? You know, the idea that we can actually, you don't necessarily need to look at the whole graph all the time.
Right. But so I was also thinking that you could use that additional information to inform your auto layout. Like you want to sort of focus on the big, right? You want to sort of bunch things up together that have large amounts of interconnectivity, like large amounts of data going between them. And then you can sort of identify, oh, these things are actually closely related to each other in terms of their actual use in the application that you're looking at. And then
like, I mean, like a tinderbox actually has a parametric view. Yeah, so like multiple views on the same thing where it's like, okay, I'm focused on this thing and we see how like where the connection. I mean, there's a lot of fantastic stuff to experiment with on the visualization side. You know, obviously my initial design is just to like get it to a point where I can build something that I could use day to day for actually doing this. But that's also why I'm actually taking the time to go back and like really spend a lot of time thinking through the rendering engine. Is that I can picture very large, like my goal for this thing would be that your entire organization's infrastructure is spec'd in this. And so then you start getting into other weird, interesting issues of like, well, how do you navigate between modules? How do you know what this thing is? What are we doing with multiple instances? But it would be so cool if you literally had a map to your entire organization's infrastructure all in one place and all in a fashion that is both queryable, visualizable, and that people could actually collaborate directly in. And obviously, right now I'm working primarily towards MVP because we don't know, like I don't know what the market's going to be interested in on either side of that. But the more I'm building it out, the better idea I'm getting. Oh, I could go do this thing, or this would have been really useful to have a couple of years ago. So like right now, I'm very much just working through the backlog of my initial idea and trying to keep it at a level that's manageable so I can get to release faster. But yeah, that's that's a fantastic idea, and I really think this is why I'm still just sort of shocked that no one's tried this yet.
Yeah, it's a really exciting idea. I mean, like as somebody who's relatively new to like the Kubernetes world, like it's kind of appalling to me that it became an industry norm that you keep your most critical application state in a place where consistency is not enforced. You have no query capabilities and composition is impossible.
Yeah.
And what's interesting is that, you mentioned Quartz Composer early on in the talk, and like one bit of like maybe open source like prior art you might want to look at here when you think about the design of this is like interesting procedural design program called Nodebox, which you can kind of think of as like an open source version of Nodebox, and it actually cites Clojure and Haskell as like direct inspirations. It's like kind of like a visual functional programming environment where you wire up nodes to each other and then values, like get propagated between them. So you can, use one node to create a grid, and then another node you wire up the circle to that grid, and that circle is located at all the grid positions. And you can even do animation with it by like computing every single frame in your animation as a function of like the current frame number. So it's mostly just for kind of like graphic design and generative art things. But like one of the things that's like I think kind of like relevant to the discussion about like the challenge of like managing visual layout that you were discussing earlier is that it allows you to manually define subnetworks and manually group nodes together and specify as a user, okay, so these are the three inputs here. It's essentially wrapping a function in another function. So it's very familiar to us. So
Terraform's like module system too, but like what's cool about it is being able to get like it's what I said before is like I think, or I've said on the internet before, is that basically Terraform needs a higher level of abstraction. So Terraform works fine, like it's a great like target format, right? But for us to manage this stuff more effectively, we need to be able to create stuff that doesn't directly impact Terraform itself, and it probably doesn't even belong in Terraform either. One of the guys that's had a huge impact on me, and I'm big into the generative art thing. I was playing with processing way back in the day, Even took a couple of classes with somebody on just how to use processing to generate like for 3D printing inputs and things like that. But there's a developer who I have to call out as probably one of the greatest living C developers right now, Eskil Steenberg. And the work he's done on interfaces, and he works exclusively in C, which he's a damn warrior. But he produces these amazing the demo I linked. It's probably my Twitter feed. Where he builds this like system for designing lighting displays, and it's all like WYSIWYG more or less, but then it can be plugged into the actual like lighting array once it's designed and costed and all that stuff. So that's something that's kind of the area I want to land in with this. And I'm mentioning Kubernetes too. Terraform's for me is like the baseline because I think it's got the broadest appeal. But I want to have this environment unifying like your CAD's configurations. I want to bring in CloudFormation. I want to bring in like pretty much all the cloud platforms at different layers. And that's why the concept of layering to me is kind of interesting. I've just got to get the rendering engine far enough along that I can start experimenting with it to figure out what the right UI is. So hi, y'all.
The floor is open for any other questions.
I just dropped a link to the Notebox rationale where they talk about Clojure a little bit in the chat. What's interesting is that you can define nodes in Clojure in Notebox, but unfortunately, I don't think it represents the state of the system as a data structure, which is the real thing that I think we're all after here.
Yeah, totally. And I think that actually this is kind of the nice things about like current approach to Terraform, right? Going back to the old-fashioned like common Lisp, like read time versus compile time. There's a lot we can do at read time or compile time versus like when we actually end up running the thing. And I feel like that again, it's like I always just wanted macros for Terraform. Now, once you start bringing the rest of the state of the system, I think that's very useful just from a visibility standpoint. I haven't really had a chance to think through the consequences of that, like once it becomes fully queryable and all of that. Actually that's where maybe another interesting kind of experiment we could go with is like, okay, let's handling an actual application to the infrastructure. Now, you obviously, I'm a big fan of CI/CD. Like we want repeatable deploys and all that. I don't want people just being able to do anything willy-nilly. However, being able to build in that logic of how infrastructure is altered into this system could also be very interesting to me. And maybe there's no there, but like I've got to get it a little further along with the rendering side before I can start experimenting with some of these way more interesting moonshots. I'll definitely check the Notebox out. I think I've heard of it before. I haven't played with it. There's quite a few actual like products out there right now where people are essentially recreating spreadsheets only more graphically. The nice thing about like Terraform or as a base design is I don't need to propagate the values live. I just need to propagate the relationships. So that actually simplifies the coding side of it a bit. There could be a fun version of it though, where it's essentially doing test applies or something where you could actually see how the whole graph's going to compile out. I'm not sure how valuable that would be, but being able to predict not just via like Terraform plan, but essentially some kind of simulation planning around how a particular change is going to impact the rest of the infrastructure. That feels like it could be pretty valuable. I'm just not sure what I would do there. The other cool idea too is like, and granted, this is me like doing too much reading on ML, but machine learning across your organization to like help optimize infrastructure. So like once your infrastructure is like a form of data that you can actually work with, if you could train the machine in such a way that like it could optimize costs on EC2 with additional data, that could be really fun.
Yeah, the whole like define it declaratively and then optimize costs, right, as part of the compiler, right?
That'd be
try
so
to figure
cool.
out what it is. I definitely got that immediately when you said that.
Yeah, no, that feels like that's probably like the long-term value of a system like this outside of just the team base.
Yeah.
Again, you put things in a database and in a structured format, you get a lot for free.
Mm-hmm. Yeah.
As long as it's the right database in the right schema.
Yeah, I think I forget the name of this project, but I think there were some people who successfully who basically this might have been an experimental project at like out of VMware. I might have seen it on their GitHub. I forget, but I'll have to dig up the name of it real quick. But related to the constraint optimization thing, like actually like it was a project where they took the state of a Kubernetes cluster and stored it in SQL to do like cost-based optimization on like usage of like cluster resources and stuff like that.
Cool.
Yeah, so that's I think that's kind of interesting prior art, but I think Datalog probably at the end of the day is a better query model for that kind of stuff than SQL is, because it doesn't squash you into tables the way SQL can.
Well, and getting into Datomic as well, like if you're putting that data in there, you're now getting to query across time, which means you get an even extra dimension just baked in that you don't get with the SQL. So, I mean, you could fake it with SQL. I've actually, the last Rails project I did, it's the first Rails project done in a few years. I basically faked a version of like Datomic's historical element, but it was a shitload of code for the result. And it took a lot of extra work to like get it done. But yeah, I mean, I think having that historical component is also fascinating because not just for cost optimization, but like you can also like you could tie that back into like your traffic or some other business metric to be able to track the performance over time. That feels like a huge steering functionality over time. And I already built basically the schema for Datomic because I mean I'm doing DataScript. I'd have to flesh it out a little bit. Even if for whatever reason I can't get the rendering to work, and I'll get the rendering to work, it's fine. It's that I or get it to where I'm comfortable enough releasing it, I guess would be the real measure. At the end of the day, though, like that Datomic component and finding a way to ingest like Terraform state into this schema, that could actually be really valuable in its own right, and it's a nice open source project for people. Where they could actually take their existing Terraform state, pull it in, and then be able to then start querying against that in Datalog. So, being a Lisp guy, being a Clojure guy, like I'm big on libraries, so I'm trying to architect everything in a way that like each piece is pretty valuable by itself. But also, the flip side of that is that like a whole bunch of awesome libraries don't necessarily add up to a product either. Also, like anybody's got cool stuff around this stuff, feel free to drop in the chat or post it up on like Meetup just to share out. Hell, maybe I'll even just start a Slack for discussion around this stuff ongoing, because I feel like there's a lot of us out here doing this and we're into it. But there's also a lot of us that are just too busy getting their jobs done to like be able to take a step back and think about it from this perspective as well.
So speaking of that, what's the best way to continue following your work?
Yeah, if you guys want to follow my work, theconsultingcto.com, just sign up for my mailing list. I'm also on Twitter as consultingcto, and you can hit me up on LinkedIn as well. If there's interest in kind of starting a more of a bigger community around this, I don't have a landing page up for Tansley yet because I've been too busy working on Tansley. But eventually I'll have a sign up for that, and once it gets into early release, I'm thinking kind of a Patreon model initially until it's a point where I feel like it's like releasable software. Hopefully we'll have that up in the next month or so. It's just gonna, obviously I've got to take a step back and rethink some of my assumptions. But in the end, you can also follow me on GitHub as well. Those are the kind of places I'm most active. My email address is directly on my website, JD at the Consultant CTO. So if you want to chat about this more, hit me up there and we can schedule time to talk. If you're in New York and you're not terribly afraid of COVID at the moment, welcome to join me for a drink at some point. I've already had COVID, so I should hypothetically be immune for a minute. But outside of that, just hit me up on one of those channels.
Mm-hmm. Okay. Well, I'd like to thank you for giving this presentation. For our YouTube audience, I want to remind you to like, share, and subscribe on the channel and the video, and stay tuned. We'll have more talks in the future. The way our talks are structured is that we normally have what we're doing for the YouTube channel is that we normally have a current talk like this one on the second Tuesday of the month, and then we have a Lisp second, which is a previous talk that we've had in the past, where we'll premiere it on YouTube 2 weeks after the second of the month. And so if you're interested, like I said, subscribe, like and share, and thank you very much for coming. And yeah, see you. Let's close the parentheses here.